Welcome to Ignite, and welcome to this session on Windows 10 for IoT, Interoperability, and Intelligence. My name is Drew Peterson, and I'm a Senior Program Manager at Microsoft. I work in the Operating Systems Group, specifically the PC Ecosystem team, and more specifically on a team called the Connected Devices team. I'm really excited to be here today. I've traveled and spoke a lot of places for Microsoft, but oddly enough, this is my first trip to Chicago, so I'm pretty excited to be here. And I'm also excited to have the opportunity over the next hour or so to talk to you guys about how Microsoft and Windows views the Internet of Things, how Windows 10 is playing a huge role to make it easier on OEMs and IHVs that build devices and ISVs who write control apps for these devices. And then we'll talk a little bit about how we believe the future of IoT will be shaped and defined via open source consortiums like the All-Seen Alliance. Before we begin, just for my benefit, how many people in this room have heard of All-Seen or All-Join? Very few. Good. You're going to learn a lot today. That's good. All right. So today we're going to go over a quick IoT overview. I'll then talk about the All-Seen Alliance. I'll describe the All-Join platform, which is the technology for connecting things. I'll talk about how we're putting All-Join in Windows 10, and how All-Join plus Windows 10 plus the new Universal Windows platform that was announced at Build last week will create powerful IoT control apps. And then finally, we'll look forward, and I can tell you how you can get involved. Probably won't do questions just because it's kind of a hard room to do that in, but I'll definitely be available after the session. If you have questions, come see me. I'll also be in the IoT booth from 1:30 until 4 o'clock today. If you have time and want to come see me there. Actually, I'm only here at the conference just today, though, so if you have questions, come see me. So IoT, it's a pretty loaded term. I had the word enterprise in the title of this slide, but I removed it just because we really don't have enterprise-specific numbers. We can really only try to gauge the growth of this area with predictions that have been made so far. And the predictions are that the opportunity is huge. 28 billion connected devices by the year 2020. That's 4 for each person on the earth. Tens of billions of dollars in the wearables market and the smart home market. But with big opportunities come big challenges. So there's proprietary hardware and protocols that complicate planning, deployment, training, and maintenance of these devices. There's manageability and configuration issues. There's identity problems, and even worse, there's a lot of security risks. So it's really still early on for IoT and to try to define this space. It's really hard to break down, but this is kind of how we see it at Microsoft, and we kind of break it down consumer versus enterprise. When we think about consumer, that's the area that's getting a ton of press, a lot of buzz. There's a lot of opportunity for sales and home automation, but it's a very fragmented experience for the end user. We see home broken down by home automation, home security, home energy management, and entertainment. When we think about enterprise, it still has yet to be defined. There's endless business verticals that have yet to be explored and defined. There's a wide range of devices from PC-class controllers to single function things that sit in a water vent waiting for water to hit it so it can report that. There's a wide range of services and apps and cloud or clouds. There's a lot of them floating around out there. And then how does something like BYOD, or bring your own device to work, complicate the company's plan for an IoT rollout? It hasn't really even been thought about yet. So since many of these IoT verticals and device types haven't really been defined, I'm going to use this consumer-esque slide just to say that today the Internet of Things is complicated, to say the least. There's tons of connected things out there, but very little interoperability between them. Each device connects to its own separate app and potentially its own cloud to store data. And these devices are separated each by their own sandbox of connectivity, or what we call a walled garden. So this promise to make my thing smart is limited because the device is only as smart as its addressable market. In a complex ecosystem, vertical solutions will be left outside looking in, And to realize value, these devices and applications must be able to connect across brands and categories. Virtually no consumer or business chooses a single brand for every product they buy. There's high licensing fees that limit deployment. There's proprietary software that increases development costs and then reduces the flexibility to the company and limits future use cases. Also, many open frameworks require a high hardware BOM, and this is difficult. It's going to make it very hard for many enterprises to deploy. So the All-Seen Alliance and All-Join framework let users interact with the things around them automatically. There's no complicated network management required, and it lets smart things work together. So before we talk about the All-Seen Alliance, we have to clear up a little bit of slight confusion with the terms. And this is widespread across every partner that we talk to. So All-Join is the name for the technology. It's an open source communication framework that enables IoT devices and apps to have interoperability. All-Seen is the alliance. That's the organization. All-Seen Alliance was started by Qualcomm. The All-Seen Alliance is a non-profit consortium that oversees All-Join, and its stated focus is to enable the Internet of Everything. And then finally, the All-Seen Alliance is part of a cross-platform Linux Foundation collaborative project. And the Linux Foundation is a great organization with a lot of really good people, a lot of great tools and processes. And right now, it's the biggest open source project in the world. So what do All-Seen and All-Join do? Why do we care? First, they exist to connect and manage and interoperate these devices. This will allow this to happen across brands, categories, transports, and operating systems. It will enable the widest range of use cases and device classes. It will enable easy discovery and interoperability. There's cloud and proximal network connectivity. It should be lightweight processing on both CPU and memory. Also distributed without charge. Free is a good thing. We're very into open source these days if you haven't been listening to Microsoft. And so the good part about All-Seen is that it's open source. It allows the companies that join, manufacturers and developers, can contribute and help shape the future of this alliance and how people participate in it. So for technology for the smart home, and I'll just use that as the example because that's really the relevant technology that people see today. It's been around for 10 years, but it's really a fragmented experience, especially for the developer. If an IHV wants to sell hardware that's connected, or an ISV wants to write an app that, to control this connected device, each company's implemented their own solution, none of which talk to each other. The integration and setup and maintenance of this patchwork system has supported an entire industry of installers and technicians and companies. And the do-it-yourself option just really isn't feasible for most people. It's expensive. It's very difficult to set up. It's not resilient or reliable. And in this slide, you can see examples of what we have classified walled gardens. So there's IHV-specific transports out there. There are ISV-specific schemas in the apps. There's OS-specific APIs, or there's just downright closed systems that nobody can get into. All-Join was created with interoperability in mind, not as an afterthought. So All-Join enables apps and devices on the proximal network to discover each other, to interact with each other for control and notifications, and to communicate in a secure way. Any ISV, IHV, or OEM can integrate All-Join into their device firmware or app. And we'll talk about how in Windows 10 we've put building blocks in there so that the integration has been done for you. A lot of the heavy lifting is already in the code. A couple of notes is that you don't have to exclusively implement All-Join, and you also can innovate and differentiate on top of All-Join technology. So what are the objectives of the Alliance? Well, it's to support the Internet of Things through an open, vibrant ecosystem and thriving technical community. The Alliance's code base is real. It's in real products that are in market today. tons that are coming. It's an open source communication platform for the Internet of Things. And the Alliance includes industry leaders and technical innovators. The Alliance strives to create a vibrant ecosystem of innovative and value-delivering products. It strives for there to be an evolution of AllJoyn from what it does today to the exciting scenarios and features that it should be able to deliver in the future. The Alliance also strives to evangelize the value of open source interoperability. And that's what I'm here doing today on behalf of Microsoft, Windows 10, and the All-Scene Alliance. The Alliance also strives to have its members contribute and use the code. Like any organization, the more involved its members are, the better results it's going to deliver and the faster it'll move. To learn more about the All-Scene Alliance, please visit the website. To find out about participating or joining the Alliance, please contact our friend Philip at the Linux Foundation. And again, all of the links and addresses in this deck should be available to you online to be able to download the deck, so don't stress yourself out about copying them down. It's all available online. So Microsoft joined the Alliance about 8 months ago. We joined as a premier member along with other industry leaders. We sit on the board of directors. We sit on the technical steering committee. We have technical PMs assigned to each working group within the Alliance. On the right-hand side, you can see community members. These are members that write a smaller check. They don't get access to the board or the technical steering committee, but they fully participate in working groups, mailing lists. They're using the code. And then on the bottom left, you can see sponsored members. And this is an attempt by the Alliance to include various technical colleges worldwide to get students involved, audience involved. One thing that I will say is you do not have to join the Alliance to download, evaluate, use, and deploy AllJoyn in your products and put them into market. It's free. But we at Microsoft encourage our partners to join the Alliance because it makes it a lot easier for us to work together to shape the future within the structure of the Alliance through the board, through the technical steering committee, and through the various working groups. As you can see from all the logos on here, the members are made up of a unique mix of silicon and component manufacturers, device OEMs and IHVs, software and middleware providers, and cloud and service organizations. I think the latest announcement was late March. They announced 22 new members, bringing the total to well over 150 member companies. So it's growing fast. There's a lot of interest. At CES, we saw a stack of cards this high of companies that were coming by the booth wanting to talk about joining the Alliance and get involved. So let's talk about AllJoyn platform. This is the technology. This is the stuff that makes it all happen. So AllJoyn solves problems in an interoperable way. First, it will help devices discover each other. Wouldn't it be great if all of my devices could see each other, if my smart dishwasher could listen and talk to my smart TV and shut down and go into quiet mode when my smart TV was on and I was watching a movie? Identity is super important. It would be great if these devices running services could identify those services. Wouldn't it be great if one device knew what the other device could do? AllJoyn is also going to help these devices adapt as they come and go. And so if you had two devices that were paired together, it'd be great if the next time they were paired, they could say, hey, we were paired. What did we do last time we were paired? And remember that. Super valuable. It'll help with management. So there's diverse transports out there. We call it radio soup. The developer should not have to know which radio transport is being used, let alone the end user. And I've got a slide later that talks about how we're going to break down radio soup. Interoperate across OSs. Right now, it's a huge problem. My house, I have all three OSs running all the time. And so having devices be specific to one OS or another makes controlling them difficult. And AllJoyn is going to solve that. The other thing is exchanging information. So one device could make another device more powerful if it knew the information and the data that that device had on it and it could share that with each other. The other thing is security. There's a lot of issues right now with security in the home automation space. We at Microsoft can't put anything into a Windows product that's not secure, especially when we start talking about enterprise. And so that's another huge component of the AllJoyn platform. Okay, we're going to geek out a little bit with some software diagrams and a little code here, but don't stress, I'm actually a partner guy, and so I learned a lot of this over the last few months. It's not very difficult. When we talk about enabling devices, we'll do that first. The Internet of Things is comprised of a really broad spectrum of devices that span from really small battery-powered sensors that sit in vents to big servers that sit in a data center. AllJoint has two device implementations that target everything from tiny things to full-blown PC class controllers. And this is done via a choice of thin or standard deployment of the AllJoint Core SDK to the device firmware or the app. If you look on the left side of the screen, you see thin core. And this is a minimalistic, really lightweight deployment. It's only 10K payload. It exposes a C API, and this is something that you would use from a small thing all the way up to a device that doesn't have a screen but is pretty powerful. For every other device, you'll see standard core, and this is a full-featured AllJoint implementation, C++. It includes something called a routing node. A routing node is a software object that has a routing table that can facilitate communication and connection and discovery between various AllJoint nodes on the network. So in order for AllJoint devices to communicate with each other, there needs to be at least one routing node on the network that's running standard core, and that device is usually going to be a PC or a phone or something with a screen that allows you to see all your different devices. The core framework of the standard core provides a C++ API and gives mechanisms to expose your device's core functionality to advertise its presence on the network so that it can be discovered by other clients and more. On top of the C++ core API is a set of what's called language bindings. These are wrappers that go over the C++ core API that provide a convenient and easy way to implement your device or app code using the platform of your choosing. So you can see that there is an Objective-C for Apple developers. There's a Java binding for Android developers. In Windows 10, we've added a Windows Runtime API. And this is exposing a C API inbox to Windows 10. And then the magenta box at the top is really just the code that you're going to write into your app. It's the UI, it's the UX, it's the graphics that you'll either write into your app, or it's the functionality that you would write into your device's firmware. And so it's a pretty simplistic setup there. It's not too complicated. And it's a pay-for-play model where you really only use what you need within the AllJoint space. And picking thin versus standard is a pretty clear-cut decision once you start talking about how powerful the device is, what it can do. So AllJoint provides something else called common service frameworks. And these are common service frameworks that are layered on top of the core framework that we just saw on the last slide. These common frameworks implement common device functionality. First, there's the about service. So this allows the device to broadcast what it is. It can say its manufacturer, it could say its model number, it could say its serial number, but this is the device's advertisement on the network to other devices. There's a notification service. So this service is used to package up notifications that the device either sends or receives. There's an onboarding service. This allows the device to be added to the network, or it can actually help other devices get added to the network because it's already been added and has all the security onto it. Finally, there's a configuration service framework that can be used to manage and control the device. And there's even a mechanism that allows a device to have its firmware auto-updated, which is really powerful. So these common service frameworks combined with the core framework provide a lot of code that you can use, as well as a bunch of samples, so you don't have to implement everything from scratch. You benefit from all of the open source functionality that's available, and you can even extend it or fine-tune it for your own purposes. So let's break that down. Here's a diagram of an AllJoint enabled smoke detector using the common service frameworks to provide functionality. So it uses the notification service to alarm a fire or to beep and let the end user know that the battery is low. It uses the onboarding service to add the device to the network via the onboard Wi-Fi. It uses the configuration service to get new firmware and to be controlled by an app or device. And then it uses the about service to be discovered by another device using device metadata. So it's a pretty simple system that allows a simple device like a smoke detector to really benefit from all of these different frameworks. And this is going to grow over time. This is just V1 we're talking now, but it's pretty powerful functionality right here today. So we've talked about hardware and enabling devices. Before we talk about apps, one thing we have to clear up is software roles. And so in this slide, we're going to talk about how all join devices talk to all join apps. It's important to understand the roles that play out here. What you see in this slide is a connected lighting scenario. So in computer science, many of us are familiar with the term client-server, where a server produces something and a client connects to it and consumes it. All-join has very similar terminology, but the words are a little different. All-join consumers connect to all-join producers. So a consumer is like a client, and you see that shown in the green box. All-join devices are producers. They expose functionality, and they allow the consumer to discover, connect, and control them. And you see that evidenced by the blue box. All-join software entities, and this can be either device firmware or an app, can either be a consumer or a producer, as you see from the smartphone app here. The smartphone app can consume data from individual lamps. And so I can turn on the light in my living room, make the light in my kitchen blue, make the light in my family room green. But within the Alliance, there's something called this lighting service framework. And this is a way where they've defined a lighting controller that allows it to consume the data from several lamps and combine them into scenes for more powerful functionality. And so come into my living room and have it automatically turn on 4 or 5 lights to all different colors and set. And I could have it say, be the night mode or the morning mode. So the lighting controller in the app allows that to do more than just communicate to one bulb. Finally, in order for there to be interoperability among devices, we need some standardization. Allseen is working on this via a variety of working groups where they're starting to define devices in their interface. There's a working group for smart lighting, smart home, connected appliances, gateway, cloud. And this is a good example of a working group and how they're defining light bulbs. If you look here in the smart lighting area, when an IHV or an OEM creates a smart light bulb, the Alliance does not expect them to contribute all of their secret sauce or their differentiating features to the Alliance. However, if we're talking about a smart light bulb, it's not that complex a device. All smart light bulbs should share a common set of characteristics that can be identified. All light bulbs should be able to report their lamp state, their hue value, their saturation, on or off. And Lifix, the company out of Australia, up-and-coming smart lighting company, has been an active member in the Allseen Alliance. They chair the working group for smart lighting, and they actually wrote the definition for smart light bulbs, and that just makes sense that a smart light bulb company would write that. They're also joined by other smart light bulb companies within that working group to discuss this, so nothing is done by one company. It's a group effort. And this is being done across the board, right now starting in home, but eventually it will hit enterprise as those devices and those verticals are defined. So Windows 10, we had a huge week last week. Hopefully you saw a lot of the press, maybe you watched some of the videos, but we had the Build conference in San Francisco last week where we basically unveiled Windows 10 to the world. You can download it, you can download the kits, you can download the tools. Please watch the keynote. There was a lot of really amazing announcements there. But we're going to put all-join in Windows 10. So when I say Windows 10 is all in for all-join, what does that mean? Well, first, we've got a broad commitment of Microsoft for the Allseen Alliance and all-join technology. We're a premier member, so we wrote a large check. We sit on the board. All-join is being included into one core for Windows 10, which means that all-join will be in PC, phone, Xbox, as well as the new IoT SKU. Putting all-join into every single SKU we make is about as committed as we can be to this technology. We're leading the charge to try to let people know about this technology, and so we had a conference in March in China called WinHEC, where we targeted device manufacturers to let them know how they could deploy all-join code on their device. There's links at the end of this presentation to these sessions, and you can download the sessions and watch them if you're interested in deploying on a device. We had the Build conference last week. That was more about creating apps on the new Universal Windows platform. Getting used to saying that. And there's a ton of sessions on IoT, as well as an extensive session on how to write a control app for your device with code and samples and a step-by-step that walks you all the way through. We're going to be going on tours worldwide where we talk to our partners in every geo about AllJoyn. Really doing that. It's kind of what I'm here doing today. And then we'll also do what Microsoft does, lots of hackfests and events for makers and things like that to get people involved. In addition to being a premier member, Microsoft is working hard to contribute to the Alliance. So we sit on the board. We have a guy on the technical steering committee. As I mentioned earlier, we have PMs assigned to every single working group. There's people like me involved in prospecting and outreach to build the ecosystem and make sure there's an addressable scale for developers. And then finally, we're contributing code. We wrote the SDK for Windows 10. We also found bugs in the Apple SDK and the Android SDK, and we contributed fix back to that as well because we're really focused on interoperability here. So when I say that AllJoyn is in Windows 10 in all SKUs, what does that mean? Well, when we set out to build AllJoyn in Windows 10, we had 3 goals in mind. First was to optimize performance and security. Second was to enable the best end user experience. And third was to provide the best possible developer experience. To achieve these goals, the first thing we did was integrate the AllJoyn runtime into Windows 10. That means that when Windows is upgraded or serviced, the AllJoyn runtime will also be serviced. And you'll hear us talk about that a lot, Windows as a service, that can be continually upgraded and patched and fixed and increased with functionality. The benefit is that you don't have to carry the entire AllJoyn payload in your device or your app library. Windows does a lot of that for you. We've also built a router node service into Windows 10, so we're running standard core in Windows 10. This is an on-demand full NT service that helps connect devices on the network regardless of whether they're running the thin core or the standard core. It's fully and seamlessly integrated into Windows 10. There's no firewall dialog or pop-up. And we've optimized the performance and functionality for Windows 10. As I mentioned earlier, we've also built C and Windows runtime APIs that will help reduce the size and payload of your application or device firmware. In addition, we've integrated them into the Windows SDK so that it's easy as possible and seamless to write applications that benefit from AllJoyn. And finally, when you're doing all this work and you're writing samples to ensure that you've got a seamless experience, you're going to see a bunch of integration with Visual Studio. We are putting all of the tools that are currently not part of Visual Studio today, but by the time we launch, they will be integrated into Visual Studio. And so everything you need to write an AllJoyn app will be in there. I'm going to talk to you in a little bit about a really cool code generator tool that we have that lets you grab device information off devices on your network. Today that's a command line tool, but at Windows launch that will actually be integrated into Visual Studio. We're also writing a ton of samples for the device classes that we know exist today that have been defined, and so it should be pretty easy to spin up as a developer and write apps that control these devices. So let's talk about building apps. There is no UI or UX in Windows 10 for AllJoyn. There's no master control panel for your things. But we've made it really easy by putting the router node into Windows and then the API to allow you to create a control app that should do more using AllJoyn. When you build apps for Windows 10 using the Universal Windows platform, there's 3 categories of code that we'll look at here. So the first on top is the code that you would write into your Windows app or device firmware. And this, again, is the UI, the UX, the graphics, the buttons, all the functionality that you would put into your app. In the middle layer, there's AllJoyn core APIs, and there's 2 of them. First, in the light blue box, you see windows.devices.alljoyn API. This offers a choice of language within the AllJoyn Universal Windows Platform API of either C standard client inbox, and this offers low-level functionality where you can really do some tweaking, or we put a Windows runtime language binding in for C# or JavaScript. So it's very easy to pick whatever language you want. In the lowest level there on the diagram, you see the standard client API in C. This includes all of the core all-join runtime library, implements all of the common underlying all-join functionality. That's connectivity, advertising, security, discovery. And this is really where you can tweak the code to get exactly what you want out of your app or device. And then finally, on the right-hand side of the screen there, in the blue boxes, you see one or more Universal Windows Platform runtime components. This is code that's generated from all-join interfaces. I'll talk about the code generator in a second, but this is going to be something that you'll use to accelerate your app development. It provides easy-to-use APIs for creating a consumer or producer, like we saw in the last couple slides here. It bypasses the low-level components so that you could start working on actual scenarios right away. It's specific to the type of device that you're trying to control, and so it's configured for that exact device. And I'll show you how we make it really easy to generate this code. So I mentioned earlier that one of our main goals was to have the best possible developer experience. And a big part of attaining that goal is enabling developers to focus on writing code that's specific to their app or device. So we're providing a code generator for Windows 10, all-join UWP developers. And this takes care of all of the boilerplate that you would normally need to write from scratch. You can go from zero to boilerplate in complete minutes, or within minutes and not hours or days. And how it works is basically you take an all-join specific device. So you either get that device's information from the manufacturer or the documentation that came with that device, or if that device is already hooked up and running on your network, we have a command line tool that you simply run. It goes out and it looks for every all-join device on the network, and then it spits back the introspection XML. And it's just 4 or 5 lines of code that the devices are advertising as part of their about service. And then that comes back in, and you choose the device that you want, the code that's there. You run it through our code generator. And the output of all that is a Windows runtime component that you saw in the blue boxes that's either a consumer or a producer. And this is code that you never touch again unless something on the device changes. And if it does, you just rerun that command line tool, grab the introspection XML, run that through the generator one more time so that you can have a new runtime component. So we're doing everything we can think of to make this super easy to include all-join in your Universal Windows Platform Control app. So UWP apps, Universal Windows Platform apps, they enable you to write code once, and then you can run it on multiple Windows 10 platforms and devices. That was the huge news out of Build last week. You can use a single layout for your app. You can tailor your app layout for different types of devices or screen sizes. And all-join is supported in all Windows 10 OS SKUs, including Windows 10 for small device IoT, Windows Phone, Windows PC, as well as Xbox. Now I have to put a little caveat next to Xbox because they're on their own schedule. They won't be launching Windows 10 when we launch Windows 10 this summer, but they will eventually take Windows 10 One Core in. And when they do, Xbox will get the Universal Windows Platform and all-join for free. And as you can imagine, that's pretty exciting to an app developer or hardware manufacturer who's making the kinds of things that might show up in a living room where your Xbox might be. It's pretty huge news. So looking forward, last week Microsoft contributed our all-join device system bridge to the All-Scene Alliance. And this is part of the first wave of enterprise-specific investments that we're making. This bridge creates virtual all-join device instances for every device that it finds on the network. In our first contribution, we included a Z-Wave-based sample based on Open Z-Wave. We've created a BACnet sample based on Open BACnet and a Visual Studio template so that the community can help us make more of these bridges. We're excited to see interest in Echonet as well as Zigbee when we have discussions with our industry partners. All versions of Windows 10 are manageable in an enterprise, and we designed our all-join device system bridges to likewise be manageable with a content security policy that runs on a Windows 10 device in the enterprise. Additionally, Microsoft is working hard with the All-Scene Alliance on the upcoming Security 2.0 specification, and that will rely on certificates and RSA keys to secure the signals methods and properties of each bus attachment and device on the all-join network. Between Windows 10 TPM support for secure key storage and key-based standards for all-join security, we anticipate enterprise-ready all-join will be ready probably in the community a little bit later this summer. And so there's things being done on the home side and also a lot of companies looking really hard at what can be done on the enterprise side. Device system bridges are pretty cool. I'll show you a slide here in a second. It'll click over. So earlier I showed you a slide that had every device in the world running all-join, and that was a little bit idealistic, where every device would natively support all-join. In real life, IoT systems are composite of a bunch of different technologies. And so for Windows 10, the device system bridge framework makes it really easy to bridge to a non-all-join device on the all-join network. So as I mentioned, we've done that for Zigbee, for BACnet, we're working on Z-Wave. We've done Z-Wave, BACnet, and working on Zigbee. Basically what that does is it creates a plug-in on the bridge to translate from that radio to a virtual all-join device. The advantages of this are that those devices can now be discovered, and there's interoperability with them, which makes a seamless app development story. The sandboxed environment that those apps live in is sometimes a lot less secure. And so when we do this translation and we create the virtual all-join device, we can actually implement a layer of virtual all-join security on top of those devices and make them a little more secure than they were in their own walled garden. And that's huge. So I mentioned Build last week. If you were in San Francisco, you heard and saw a lot. You can definitely go online to buildwindows.com. We had a bunch of major announcements. First, Insteon. Insteon is a co-engineering partner with us for Windows 10. We've been working with them for over a year now. They announced their very first all-join enabled Hub Pro for Windows 10. You can pre-order that now. There's a 10% off developer special. You come see me, I'll give you the code. Insteon, if you haven't heard of them, has been involved in home automation for 30 years. They're a super deep player with a long track record of working on IoT before there was an IoT. They're taking a leadership position in the Alliance, so they're part of a bunch of working groups. We work with them a lot. And then this announcement is huge because they have over 200 products for home automation. And with the announcement of this hub being available for all-join in Windows 10, it lights up all 200 plus of those apps for you, the consumer, and you, the developer. So we're going to scale quickly with a partner like Insteon. That links to their press release where you can learn a little bit more about that. The other announcement we made is we had both of the CEOs of these companies on stage with us to make these announcements last week. Lifix is an up-and-coming smart light bulb company out of Australia. They just announced new bulbs. They're white tunable 800 lumen bulbs. They also make a 1,000 lumen color tunable bulb. It's one of the better solutions we've seen. Super bright, very responsive, Wi-Fi, no hub required. So what they announced at the show was this new light bulb, and then they came on stage and they showed their app in UWP form running on our new platform at parity with iOS and Android before the tools had even been released. And if that wasn't cool enough, the vice president of that company grabbed his phone and has plumbed into Cortana, and so there's other goodness you get by being a developer on Windows. He was actually able to turn on and off the smart lights on the stage, telling Cortana to do so. A little bit of lag if you see the video, but trade show lag is there, but it's real, it's happening, and they're super excited. And so at launch, that app will not only be at parity with iOS and Android, but it'll have extra features like live tiles, where you'll be able to pin light bulbs to your home screen to control them, and then you'll be able to tell Cortana to turn on and off your lights, which is huge. The other thing we announced was Visual Studio 2015 all-join integration. So we're putting all of the tools into Visual Studio. You'll have a one-stop shop to write a control app for your devices. We announced all scene and all-join specific sessions on UWP apps. There's links to those in this presentation that you can watch. The guys had a bunch of gear up on stage, and they actually built a toaster with a Raspberry Pi 2 board control. It's the world's first connected toaster. We don't see a huge market for that device, but it actually was a great demo device, so watch that video. And then finally, we wrote a bunch of Windows 10 all-join samples. So for every kind of connected device that there is a definition for, we've written a sample that allows the developer to quickly spin up and write a control app for that device. So at the end of all these things, we call to action. What is that? First, join Windows Insider. This is how you can get and install Windows 10. You can get that today. If you are a Windows Insider and you continue to be a Windows Insider, even after we launch Windows 10, it's a way that you can get early builds. It's a way that you'll get functionality before the whole world gets it to test and play with it. AllJoin is in that build today, as well as the API. Build AllJoin enabled apps and devices. If you need help getting involved with that, come talk to me. But the more devices that are out there, the better. The more apps that we have, the better. And it's funny, IHVs are writing their own control apps, but many of them have their own SDK. They don't have thousands of hours to write these apps, and so they actually welcome third-party developers to do that. And what we're waiting for with AllJoin is the first final device that's going to come out, or app that will come out to control the majority of my devices in my home instead of me having to pick up 5 different devices. Send us your feedback. So as you're building these apps, as you're deploying AllJoin code on your devices, there's a variety of aliases on MSDN that allow you to tap in and give us feedback. There's a bunch of teams especially designed to AllJoin and AllSeen that would love to hear from you. Get involved with the AllSeen Alliance. So like I said earlier, you can go to their website, you can download the code, the documentation, you can play with it, it's free. You don't have to join the Alliance or write a check. If in evaluating it, you think it's a good fit for your business, joining is a nominal cost, but there's great benefits with joining the Alliance. Philip at the Linux Foundation is a great guy that can really talk you through what those benefits are. And finally, if you're going to join the Alliance, get involved and contribute your code back to the Alliance. Again, we don't expect partners to contribute their secret sauce or their differentiating factor back. But the more companies that get involved in the Alliance and the more companies that are active, the faster this will grow and the faster we will have not so much fragmentation out there in the IoT space. There's a couple other sessions here at the Ignite conference that are being run by my colleagues from Microsoft. So there's a Windows 10 and the Internet of Things session by Colin Murphy later today. There's a Microsoft architecture for the Internet of Things being done by Kevin Miller. There's a Windows 10 for small devices. That's a new SKU that was just announced that allows you to run Windows on a small SKU without a screen, so like a gateway. Colin's going to do that as well. And then there's a Create Your Internet of Things using Microsoft Vision by Sam George. And I think all 3 of us will be part of the IoT booth downstairs if you want to come talk to us. Finally, there's a ton of resources out there. There's a ton of things you guys can go do after you get home from this conference. First, if you're interested in building devices, please go to the session at WinHEC that we did on enabling IoT devices with AllJoin. It's a pretty robust session, lots of demos, lots of hardware on stage that really talk to you about how to put that thin client into the firmware of your device. If you're interested in building an app that controls these devices, please go to buildwindows.com. You'll see an extensive session with the longest session title in the history of session titles. That was a good session, though. That is the session that we had Insteon and Lifex on stage doing the demos and talking about how to build an app. There's also something called the IoT Show. Channel 9 is Microsoft's online TV station, and they've spun up an IoT show. I think it's got 4 or 5 episodes now. They shot one from Build last week, but it's basically key members of each group around Microsoft getting on a stage and talking about what they're working on. Guys from Windows, guys from our IoT team. So it's a really good show. You should check that out. And then if you're interested in AllSeen, obviously you can go to their website. There's Windows 10 on IoT is the new small device. There's a website dedicated to that. There's a ton of documentation on MSDN for AllJoin. And we've also written a bunch of samples. And so if you go to buildwindows.com, you can get that. The other thing is if you're interested in that device system bridge I spoke of earlier, this is a link to the white paper on the Alliance website that they just accepted, explaining more about these device system bridges and how you could build your own. And with that, I thank you very much for attending this session. I'll be available afterwards. If you have questions, please come and see me. Again, I'll be downstairs at the IoT booth. Have a great rest of your week, and please look into AllSeen and AllJoin. Thanks.